Hi, Pre-Calculus. I hope you are well and managing e-learning. I hope you're getting outside and getting some exercise and some fresh air. I happen to be home alone at the moment, just me and the dog, so I thought I'd try to get a few videos done, and I'm hoping he's not going to interrupt, as he has done several times now when I've been doing geometry videos. But we're in section 7.2, systems of equations. I feel like this is a lot of review for you. I know you did systems in algebra and also algebra 2, but we chose, or Mrs. Paul actually chose, primarily application problems for your homework. And so I wanted to go through an example on video, just one that relates to one of your homework problems. I'm looking at example 8 in your textbook. I was going to just have you reference that on your own, but as I read through it myself, I felt like at one point they simplified an equation without a whole lot of explanation, and I thought it could be a little bit confusing. So I'm just going to work through this problem, give you a little different approach than what the book shows. But it's an airplane. An airplane is flying a 2,000-mile trip, and on the outbound flight there is a headwind. The plane is going against a headwind, and the flight time is 4 hours and 24 minutes. On the return, the wind is actually kind of at the plane's back, so to speak, so the wind is helping the plane, and the flight time goes down to 4 hours. And the question is, what are the speeds both of the airplane and of the wind? So as always, in a word problem, application problem, we want to clearly define our variables. And this problem is one of our classic distance equals rate times time problems. So let's do a little simplifying before we start writing equations. I'm looking at this time here, 4 hours, 24 minutes. Let's get that just in the form of hours. So we would think of this as being 4 plus 24 out of 60, 24 minutes out of 60 minutes, hours, which simplifies down to, we've got a trip here of 4.4 hours. Return flight nice and even, 4 hours long. So let's think of the original flight. And diagram it a bit just to understand what's happening. We've got a wind, and the wind is actually against the plane. So the wind is slowing the plane down. So if we're calling the rate of the plane R1 and the rate of the wind R2, the net speed of the plane is going to be the speed minus that wind speed. So R1 minus R2. For the return, we've got the wind and the plane same direction. So that net speed is going to be the rate of the plane added to the rate of that wind. So let's look at some equations. Classic distance equals rate times time. Our distance is 2,000. And for the original flight, our net speed, our rate, is R1 minus R2 times the time, which for that outgoing or original flight is 4.4. And I'm going to distribute that 4.4, and we'll end up with 2,000 equals 4.4 R1 minus 4.4 R2. Okay, so there's our first equation based on the information we have about the original flight. We can write a similar equation for the return flight. Again, it's still 2,000 miles. The speed is going to be our R1 plus R2, and this time we had a nice even 4-hour time. Now I could distribute the 4 here, but what I notice is that if I divide both sides by 4, I'm going to end up with a nice even 500 here. So I'm just going to do that so that my coefficients of my rates are 1, which is convenient. So let's look. We could, this is set up nicely to do substitution, but that was the primary focus in 7.1. So let's take a look at how we would use these 2 equations and do elimination. So here's our first equation and our second. And I would like to cancel out one of these variables. And what I notice right away is that the coefficient of R2 is negative and R1 here is positive. So if I just multiply this equation times 4.4, I'm going to end up with coefficients of R2 that are opposite, and they will cancel each other out. So I end up with 2200 equals 4.4 R1 plus 4.4 R2. When I add those, the whole point was I wanted the R2 term to cancel out. So I end up with 4200 equals 8.8 R1, and that gives me a rate of R1, that's the speed of the plane, of approximately 477.3, and that's going to be miles per hour. So at this point, we've got a real simple substitution. We can plug that 477.3 in to our equation here, and we end up with the rate of the wind being 22.7 miles per hour. So you have a homework problem that is similar to this, so hopefully that is a little bit of help. Please reach out to me if you have problems doing your homework. Use that Ask My Teacher feature on WebAssign, and I will be standing ready to answer your questions during your class period time. So take care, everyone, and let me know if you have questions.